Okay guys, so good day again. This is page 2 of your notes. So here's something that we need to consider, and this applies to graphing 2x2 systems. Now, 2x2 systems, 2 variables, 2 equations. When the equation in a system can be graphed, then the solution to the system can be described using the coordinates of the point of intersection. Now I know that was a lot, so I'm going to fill it in. When the equations in a system can be graphed, then the solution to the system can be described using coordinates of the point of intersection. Okay, so you may be saying, Miss Gable, what you mean? Hold on, I'm gonna let you know. Like that this one fits so perfectly. So let's go one by one and look at the lines. Now I'm gonna just cover this up because I want this out of your view, kind of, sort of. Okay, so the first thing that we have to consider is what type of lines do we have if we end up graphing these things. Okay, these lines here are an example of lines that are parallel. And what type of system do we have with parallel lines? These are consistently having the same slope. They will never, ever, ever touch. So the word here, we call these inconsistent lines. What type of solution do we have here? We have no solutions. Same slope, parallel, no solutions, never intersect. Okay, so just some other vocabulary that may come up. Sometimes the empty set is used to describe the solution to such a system, and the symbol for that is just a 0 with a line through it. We may not see this as much, but it can come up in a later class, okay? So that's what we have with parallel lines. No solution. If I was going to say what's the most important, if your lines are parallel, you have no solution. All right. Then we have lines that are intersecting. We can't say that those are perpendicular because at the corner, it doesn't make a 90-degree angle. So we have lines that are intersecting. Now here, the type of system is considered consistent. And I'm just filling this in just so that you have it as a point of reference. But what's most important here, if you have any type of intersecting lines, does not matter. Long as they meet, then it has one solution. And that one solution is represented by the point of intersection. And it can be written as an order pair. They will write kind of big. Sorry about that. Other vocabulary: if the two equations in the system graph into the lines which intersect at a single point, then they are called independent equations. All right, may come up later on, but for right now, all I need you to know: if you got intersecting lines, they have one solution. Done. Okay. Then, if you have lines that coincide, meaning, and Ms. Gable don't have a color printer, but meaning you have two lines and they are right on top of each other. One line is a solid line and the other line is a dashed line. They are the exact same line. Then they have a consistent set of solutions. And in this case, the type of solution that we would have an infinite number of solutions. Every single point. I'm going to put an infinity sign. I started to spell it out. An infinite number of solutions. All right. Excuse me. An infinite number of solutions are every point on the line. Okay. If the two equations in a system have the same graph, then they are called dependent. They depend on each other. All right. But what's most important, if you have lines that coincide, think about that as being lines that are the same, then you're going to have an infinite number of solutions. Okay, that is what's most important about what you have here. So just focus on what you see here as the stars, or the little asterisks, however you want to describe them. But this part right here I would consider to be most important. All right,